Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkleberg.
And this is Kirk Gray.
Hey, Kirk. This morning I got a survey. It's not technically a question from one of our listeners, or maybe that's why I'm not getting the survey. Yet it was about my opinions or insights or info or whatever. I didn't take the survey yet. It was on the impact of the Internet of Things, the interconnectedness of our equipment, machines, and factory systems and all that. Is more on the factory side to the cloud. And with its impact on predictive maintenance, precision maintenance, with, preventative maintenance. It goes to everything from oil analysis to vibration analysis, thermal imaging, and also voltages and currents and all kinds of other stuff that we can measure. And now instead of doing spot measurements walking around the plant or only in diagnostic mode, it's now collecting a lot of that stuff all the time. And you were just talking about the pinball machines, our favorite topic.
A very old industry since the 1960s or even earlier, I think. But they have now incorporated, and they've all seen, all the manufacturers, mainly one, has seen the value of the internet and interconnection. And Stern has, the main manufacturer, probably has 96% of the market, has added a QR reader to every one of their machines and a Wi-Fi interconnection to the cloud, to their systems that log and keep scores. And now we can compete internationally with other people all over the world on their machines and kind of have comparisons. And there's all kinds of other things they've added, achievements. They can actually download a new software code to have for just a day of special events or something like that. But one of the things we were just talking about, and we know other companies do it, and that is send back failure information. And I haven't really investigated whether that their new interconnection to the world, to the internet, and to their own servers and systems, whether they're including the failure information, which would be very valuable for them.
Well, failure or usage is
usage, right?
Just if something. One of the things I learned years and years ago, and it wasn't that the inkjet printer heads, the actual print head itself, has a small chip on it that would record how many times the nozzle number 87 fire, per day or per hour or whatever. It was all done so that it wasn't user identified and you couldn't tell what somebody was printing. Yet it was only collected and read when you recycled the print head, right? You turned it in and you got some money back, credit for the empty cartridge. The value of that is that little chip would collect, and they would do the failure analysis on it. And they quickly realized that some failure mechanisms only happened when it wasn't being used very much. And then there were other failure mechanisms that only were occurring when it was used a lot, and it's same with lots and lots of products. But if all you get is the failure information, the power supply failed or the keyboard failed, and you'd have to do a lot of digging to figure out, what were the usage conditions that could cause this? Where what they were doing with this, they were gathering that data so that when they got the failed unit back, they could look at what the failure was, and then they could say, wow, this thing was used all the time. And so that makes sense because that wears out this thing. And there's cars that do that. There's airplanes that do telemetry stuff. There's all kinds of systems. Do you remember it was I think it was Maytag or somebody else. There's a kitchen scene in the commercial and somebody's knocking on the back door and, hi, I'm here to fix your refrigerator.
Well, it called.
Yeah, I didn't call you for that. Your refrigerator did.
Yeah, exactly.
Which kind of creeped out a bunch of people, and you didn't hear about it again for years. But
your refrigerator better notify you that you called the repair.
Yeah, there was a bit of a privacy issue there, kind of thing. But the
Right.
idea is that
But yeah,
our
we see that
systems tend to know if they can know. It doesn't.
they can
It has
know.
to be designed such that you can tell. Oh, this motor's running way more often than it
Right.
should, or
Right.
this light bulb's not working, or
Right.
this op amp is malfunctioning.
Right. And we see that that's been on for, in cars. There's always some diagnostics. Now there are computers, of course, that you can plug into. And I know that the modern electric car companies like Tesla have a constant feedback to the servers, to their home base on what's going on with the car's performance,
I ran into
all those factors.
a university guy at a conference that his group and his area research was collecting this kind of data, working with like Mercedes and VW
Right.
and other companies to say, and they were purposely collecting telemetry data. How hard were the braking? How hard were the turns? At what speeds were the turns and stuff like that? And using that information back in the design team to design suspension systems that actually could work over the actual range of uses.
Right.
And so they were, and I remember way back when I was at Hewlett Packard, is a guy sat across from me that would put these little sensor bundles in it that had a memory in it, and it would measure temperature and vibration and shock and all this other stuff. And he would ship it to one of our other factories across the country and ship it back. And he was to the point where he could say, I heard him on the phone one day. He called UPS and said, I understand you changed the height of the drop on conveyor number 17 in your plant in Nashville. And he's like, they always seem surprised when I know that.
Right.
But when the shock goes from a 1 foot drop to a 2 foot drop, he could tell. And so it was like, and he knew enough about the shipping business that was what he was doing and monitoring all the time. But he was able to collate that data, and we put it into design guidelines that said, if you're shipping by UPS, or it's this kind of package you're doing, FedEx or US, whatever system you're using, here's the temperature ranges, here's the seasonality of it, here's the shocks and vibrations it gets, and here's all this kind of stuff. So it wasn't a standard that was devised 40 years ago.
No, it's based on real
data.
Right. And Dell would do that too, where they would send a box with a bunch of sensors in it that would record the trip.
Yeah.
And then they get it back and look at the profile, the vibration, the thermal issues, and but of course
now we're moving it into maintenance. So that's what made me thought of it with your when you were mentioning this barcode and for playing, for different events and tracking information and stuff. And I thought, well, that's cool. I think the real money is in the information gathered about, is it working or not, and what's not working, and what's about to fail, or how's usage affected.
And I've mentioned that the pinball equipment manufacturers are not focused on necessarily reliability, because traditionally and historically, pinball machines we always know, because they're electromechanical, that they're going to require maintenance. Now that's 90% is on the mechanics, of course, but
the money is not the same with a pinball machine. If 20 of those 22 machines were not working, there would be a problem. Yep. At any given time. But in a factory, like let's say the Tesla factory, if one of the welders goes down, that stops the whole line.
Right.
And they're not making another car that hour, or minute, or whatever it is their rate is.
Right.
A lot of the factories that, many factories I've been in, know that the cost per minute of lost inventory, of lost sales. And in those places, they are embracing this telemetry stuff and going, if I know at the end of the shift, we've got a shift for maintenance coming up, and I know that these 3 tools are showing signs of alignment or wear or drawing too much current or whatever, then I can go fix those before they actually fail. And I think that's where this telemetry, the ongoing continuous telemetry, is a game changer, because
it
really
is. There is a cost to that, and that's the question that I have for this particular my particular field of pinball, loving pinball, is the fact that every time they add a feed, they've added this QR code reader now. They've added the Wi-Fi a chip, and so now they have interconnection to the internet. Now they are very slow on releasing code. Most pinball machines are released with very low code, and now that the Wi-Fi can actually automatically upload, just like your phone or whatever, when an update comes, they are updating all the time. It used to be they had to use a thumb drive and plug it into the machine. Now they can update it automatically. Question I have is whether they have found value. Now I may try and check with them to get the feedback on the diagnostics, because all the machines have built-in test diagnostics. You can test coils, you can test all the circuits, you have all built-in self-testing that occurs every time the machine starts up.
Oh, that would be freaky if you're doing the cleanup for the restaurant or bar that these are in, and at 2 a.m, one of the machines lights up and bings and bongs and goes crazy, and then quiets, and then the next one goes off.
They can in the PC industry. There's some ways of turning on the machine that seems to be turned off. No, there's still a physical switch.
Oh, okay.
They're not doing that yet, but yes, that would be scary. Be like a Twilight Zone episode, I remember. Anyway, that's a cost, and they're always very slow at developing cane code. So adding, diagnostic transmission back to the factory, and the importance of that to them, I don't think is that high.
If they're not a high priority to, hone the edges of their machines, make them the next reliable, they're not going to send a repairman out that's local.
Let's just say that pinball, the industry is not focused on reliability. There's a high tolerance for unreliability, and it just comes from historic understanding.
One of the issues I've run into with this Internet of Things is companies are selling these little wireless vibration sensors, basically.
Right.
You can stick them on machines here, there, and everywhere.
Right.
And you get a whole case of them, and you put them all over the place. A little bit of thought should go into where and how you use these things and stuff, because you turn it on and now you've got this vibration spectrum getting sent to your memory all the time. And now you've got, and I've been in so many factories, they have terabytes and terabytes and terabytes of data every day getting gathered on their factory floor. And nobody's looking at it. Nobody's using it.
What are they doing with it? It doesn't help to gather data if you don't have any analysis of it.
I look at it as if that diagnostic and telemetry stuff, and let's say it's a bigger facility and has 1,000 pinballs in it, machines in it, then, and there's somebody that's on staff to maintain them, right? That diagnostic might be actually pretty.
Machines, that'd be about 100 technicians.
All right. But the idea would be is that local information and troubleshooting and everything else would not involve getting on the floor and opening it up while, kids are running around with their sodas and all those kinds of issues. The idea is that it is valuable information if and only if you use it. And so like in a factory, if the team has a good set of diagnostics and the machine has the capability to do it and you use it, then it makes sense to use Wi-Fi or other telemetry gathering and analysis to streamline that process. What I find is that a good number of companies go, oh, that looks cool. Let's buy a whole bunch of sensors and stick them all over the place. And then they don't have anybody to look at the data. And then the IT guy's going, hey, I need to get another server farm here going because we got so much traffic and so much data.
And just it's just like parade, what was it, CPK or the control charts?
Oh, it was on everything. I put a control chart on a water fountain one time because I was trying to figure out, I had to do something that day, so I put one on there.
Yeah, it was wallpaper. Everybody had these control charts, but nobody was looking at them. It was like, oh, okay, that's what, Dr. Deming told us to do. No, that's not what he did.
But I think you automate a process that is working. You do it manually, make sure it adds value to your system. and then automate it. I find the Internet of Things has got that backwards. They're saying, oh, you can make this automatic, you can Wi-Fi this, you can collect this data and everything else. But then they stop short of, well, what the hell do you do with it? And if you don't already know, automating is just going to, what did they say about computers? Is I can make mistakes quicker and faster or something like that?
Well, yes, that's true. If they're programmed by human, they can. So, but the fact is that the internet and Internet of Things is allowing a lot more opportunities that weren't available before, as far as reliability, diagnostics, and feedback that we didn't have in real time that we have now.
Yeah.
And if companies are wise, they will invest in early analysis of those kinds of that data coming back from the field, because you don't have to open the machine necessarily. You don't have to have somebody go probe the voltages of something.
Yeah, you don't have to have the vehicle in the shop to read it.
You're right.
You
can see exactly what's
fail.
Right, and you can see trends, and you can see.
Well, how important is it to? I mean, we've talked about the importance of failure analysis and troubleshooting failures and understanding trends and failures and all that kind of stuff.
Mm-hmm.
Isn't there like a whole nother industry that would touch on the majority of products that are made in the world that just work? What is it about them that makes them just work for a long period of time? What sets them apart from the ones that failed? Because we collect a lot of failure data, but we don't collect a lot of success data.
That's true. That's true. And that's kind of like, a pinball machine that never failed for 3 years. You'd really want to open it up and
well, don't touch anything.
Look at it. So, that kind of thing. But again,
it's the one that had retrofitted. Maybe it was the one that you stuck a set screw in on the flippers and didn't tell anybody, and that's why it's working for 3 years.
Well, and just the fact that it's a hand-assembled play field underneath, and there's thousands of solder joints, connections, and the machine does vibrate, and in fact, it has most of the modern pinball machines, the higher-end models, have an actual vibrator motor offset mounted inside to shake the machine.
Mm-hmm.
To actually, the machine vibrates.
Sort of like your phone. I always wondered about the vibrate mode in a phone.
Than that. Oh, man,
I'm sure it's a big machine.
Right, and people shove it and kick it, and those kind of things would be good to monitor if you had an accelerometer in there. They don't. Pinball machines don't have accelerometers.
Well, you could fix that. You know how to do those.
Oh, well, I do, but that would be another, $500 expense on their part. And if you dominate the industry and you're really not worried about your competition, that's not something you're going to do. Yeah. So, well,
fortunately, the vast majority of the people that listen to us and are not in the pinball industry and actually have to care about how their customers use their products.
Yeah, exactly. But no, they care. I'm not saying that Stern doesn't care. They've actually sent me free parts, multiple parts for free when they realized something on my, it's amazing. The designer of the machine follows the Facebook posts on and about and from users, and he was the one that contacted the designer of the machine. Contacted me and had the parts department send me multiple parts. So
that's customer service.
That's customer service, and so that's what if you're nothing else, you're keeping your ears open to the media current and whatever your industry has, channels in the professional fields you're in, and will listen for negative feedback. And
there's a whole nother episode there about episode. Well, how about how organizations shield their designers from anything? We have layers and layers of engineers and call centers and third-party shops that never communicate back to the design team.
Exactly. It's a long telephone exchange.
Yeah.
Anyway,
but I think it's out there in places where people have got a reasonable system and are collecting usage data, or they're collecting, real data, the automation of that and the Internet of Things just makes that easier and more convenient and all those things. So I think
Right.
those are a natural.
And it's being more and more adapted, and as engineers learn how to use it, it's going to be more standard that you're internet connected, you're getting real-time data feedback from the field. And
there are privacy issues with all of this interconnected stuff.
You're right.
But if I'm running a factory, I want to know how my machines are doing, and let's figure out what we need to know and let's make it work.
Right.
It's coming. It's been a decade or more that the systems and automations and so on have taken hold. It's not trivial. You got to really know what you're doing and think it through and use the data.
Right.
If you just collect it, you're kind of wasting a whole lot of time and energy.
And you can't monitor everything, so you got to get the critical point factors. So
it's anyway. So I'm not going to ask you about pinball machines because I want to wrap this one up again.
I know too much.
Yeah, if you want to learn more than you need to know about pinball machines, ask a question about that. If you, and if you're using some version or flavor of this Internet of Things and collecting data remotely or through the internet of some sort or another, or some internal system, where do you find the real pain points, or where do you find the real benefits of it? And let us know. Head over to accendoreliability.com/go/SOR. And Kirk and I and the other hosts are available through LinkedIn and our About pages. So plenty of ways for you to get in touch with us. So once again, Kirk, I imagine you're going to head off to do some more testing of pinball machines.
Yes.
Sneak some diagnostic equipment in them.
No, it's funny because the pinball machines are so deep and complex now that some people wouldn't know certain things fail. That's the problem. That's, I know what sensors are not operating, what targets are not registering, whereas the average person would say, oh, it rang and did bing bong, that kind of things. But they're lucky because
you got one eye on the scoreboard. That's you.
To do. Yeah, I know what this machine is supposed to do when it doesn't. So that's why they value me and sometimes provide me free games.
There you go. Good for you.
So,
you're providing a service to the pinball industry.
I am.
Well, carry on, Kirk. Carry on. We'll talk to you soon.
Okay, bye.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.